All right, going on to 6.5, distributive property. We just got done with scientific notation. Next up, we have one-step equations. So today we'll be able to explain why we use a distributive property. We're going to use the distributive property to evaluate numerical expressions, and then we're going to use it to simplify algebraic expressions. Okay, so first off, we have our vocabulary, which is distributive property, which should be on page 4. Okay, so we're on page 4, letter D. Distributive property, it's in the middle on the right side. Okay, so the distributive property is a property that allows us to get rid of parentheses spelled that wrong, sorry, when there's multiplying and dividing, or when there's multiplying and adding. Okay, so for example, if I have 3 times 10 plus 4, I can rewrite that as 3 times 10 plus 3 times 4. Because otherwise I'd have to add these together first and then multiply by 3, which you could do in that case. But when I have all variables like A times B plus C, I always go pew, pew. Making the sound effect actually helps. So A times B plus A times C. And then we can simplify it further. Okay? And the personal connection is I feel like these are lunch ladies. Or lunch staff, I should say. So lunch staff handing out lunches to each student. Okay, so we're handing out that A to each part. Okay, so we're going to build some backgrounds real quick. Okay, we're going to create 3 like terms. Okay, so 3 like terms. So let's pick x. So it'll be like 7x, negative 15x, and 22x. So those are all like terms, or things I could add together because they're all x's. Create 3 unlike terms. So if I stick with that x, I could start with 5x. Now what's something I could not add to 5x? I couldn't add a's, so we're going to say 16a. I also cannot add constants, so like negative 14. Things that don't have variables. So none of these I could add together. They're unlike terms. Okay, we're going to use an array to show 3 times the quantity of 4 plus 1 in 2 different ways. Okay, so to do that, we're going to start with 4 plus 1. 1, 2, 3, 4, plus 1. And now we're going to do that 3 times. So 1, 2, 3, 4, plus 1. 1, 2, 3, 4, plus 1. Okay, so that would be, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Plus, and then this is 3, so 12 plus 3 is 15. Another way we could just do that is 4 plus 1 is 5. So we're just doing 1, 2, 3, 4, 5, 3 rows. And we get 15. Okay? Now in this case it didn't really matter. I could have just done 4 plus 1 is 5 times 3 is 15. And then here I get 12 and 3, which is 15. But in this case we have to use it to get x's. Okay, so I'm going to start with x plus 7. So I'm going to actually say x, and then plus, and then 7 dots. 1, 2, 3, 4, 5, 6, 7. And we're doing it 6 times. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So how many x's do we get? We get 1, 2, 3, 4, 5, 6. So we get 6 x's plus, and then over here we have, it's going to end up being 42 dots. So another way we could have just done this is 6 times x, done that first, and then 6 times 7. We get 6x plus 42. Okay? So number 1, we're going to evaluate this expression using the distributive property. 6 times the quantity of 10 plus 9. So we're going to rewrite by multiplying each factor by 9. So factor is what's inside the parentheses, so 10 and 9. And we're not going to multiply by 9, we're going to multiply by 6. That was my bad typo. Okay, so we're going to do 6 times 10 plus 6 times 9. So it goes pew, pew. And then we use order of operations. So in our order of operations, we multiply before we add. So I'm going to do 6 times 10, 60. 6 times 9 is 54. If you need to use that multiplication chart, you can. And then we're going to add. If you need to rewrite it so it's vertical, you can do that. 0 plus 4 is 4. 6 plus 5 is 11. So we get 114. Now, without you knowing it, you really just did 6 times 19. Cool, cool. Okay, so number 2, we're going to evaluate the expression using the distributive property. So 7 times 32. So we're going to rewrite 32 as 30 plus 2. And then we're going to rewrite, so we're going to write it as 7 times 30 plus 2. So we're going to write you rewrite by multiplying each factor, that's the 30 and the 2, by 7. So I'm going to take this and I'm going to go pew, pew. So I'm going to do 7 times 30 plus 7 times 2. And then we use our order of operations, which means to multiply first. So 7 times 30 would be, this 0 just stays 0, and then 7 times 3 is 21, so 210. Plus 7 times 2 is 14. So now I'm going to add those. 210 plus 14. This would be 4. 1 plus 1 is 2. Carry down the 2. So 224. So sometimes you all are like, how did you do that so fast when I multiply things? And it's because I use the distributive property. I don't know what 7 times 32 is, but I know 7 times 3 is 21, add a 0, and 7 times 2 is 14, and then I can add them together. Okay, back side. Alright, so now this one we have a variable. So if I was just going to solve this, I would have to add 4 to it before I can multiply by 6. So currently there'd be nothing I can do. I can't get rid of the parentheses because it's not all adding or all subtracting. And so I have to do it exactly how it is. But now we can use the distributive property. So the first thing we're going to do is rewrite by multiplying each factor, that's the u and the 4, by 6. Okay? So I go pew, pew. I'm going to say 6 times u plus 6 times 4. Now I'm going to use the order of operations, associative, and commutative properties to combine like terms. This is a u, not a 4. It kind of looks like a 4. So 6 times u, another way you can write that is just 6u. I can't actually multiply them. Plus 6 times 4, which is 24. These are not like terms because this says a u and this does not. So this is my final answer. Okay, number 4. First thing we're going to do is rewrite by multiplying each factor, which is the 3e and the 5, and it's really a negative 5, by 4. Okay, so what I did in my head is I'm going to make that into adding the opposite. Okay, I went from a positive 5 to a negative 5. Now I'm going to distribute. Pew, pew. So I'm going to write it as 4 times 3e plus 4 times negative 5. Okay, so this is really like 4 times 3 times e. And I can do that 4 times 3 part. So 4 times 3 is 12 times e. So when I do this, I just think 4 times 3e. Oh, that was a bad v. It should look like this. 4 times 3 is 12, so it's going to be 12e plus, and then 4 times negative 5. So that would be 4 times 5 is 20, and then a positive times a negative is a negative, so negative 20. Okay, another way you could write that is 12e minus 20. Either way works. Okay, number 5. We're going to simplify this expression. So the first thing we're going to do is rewrite by multiplying each factor, which is just the 6h and the 2. Okay, this minus 9 is not a part of it. It's just the 6h plus 2. Okay, as multiplying. So we're going to do 5 times 6h plus 5 times 2. And then we're going to change that subtracting to adding, and the opposite of 9 is negative 9. But I'm not multiplying that by 5 because 5 was only being multiplied by this expression. So 5 times 6h is going to be 30h. 5 times 2 is 10, and then plus negative 9. So now I have like terms. I have a 10 and a negative 9, so I can combine those. I'm going to put parentheses around them using my associative property. So I get 30h plus 10 plus negative 9, positive and a negative, so when I add a positive and a negative, I actually subtract. 10 minus 9 is 1. I have more positives. Okay, lastly we have number 6, simplify the expression. 7 times the quantity of 2y minus 4 plus 3y minus 8 times the quantity of y plus 1. So it's really important in this case is we do have to change subtracting to adding the opposite. So I'm going to rewrite this as 7, 2y. I'm going to change this subtracting to adding. Opposite of 4 is negative 4. Plus 3y. I'm going to change this subtracting to adding. The opposite of this 8 is negative 8. And then y plus 1. Okay, now we're going to use the distributive property. We have to use it twice because we have one here and once here. So I'm going to start here. Pew, pew, and it only goes with the parentheses. So 7 times 2y plus 7 times negative 4. Okay, now this 3y is just hanging out. But this one I have negative 8 times. There's a times here secretly hiding. Okay, so I do have to distribute this. So negative 8 times y plus negative 8 times 1. Now order of operation tells me I have to multiply before I can add. So I'm going to multiply everything now. So 7 times 2 is 14, so it'll be 14y. 7 times negative 4, 7 times 4 is 28. Positive times a negative is a negative. This 3y was just hanging out. Negative 8 times y, we can just write that as negative 8y, because that's what that really means is we're multiplying those two. And negative 8 times 1, 8 times 1 is 8, and negative times positive is just a negative. So now I'm going to use my commutative property and rearrange and put my like terms together because I have a 14y, a 3y, and a negative 8y. So I'm going to put those out front. 14y, 3y, negative 8y. Then I have my constants, negative 28 and negative 8. So 14y plus 3y, I add my coefficients. 14 plus 3 would be 17. So I get 17y plus negative 8y plus negative 28 plus negative 8. I'm running out of space. So now I can combine these two because they're both y's. So 17 plus negative 8, I have a positive and a negative, so I subtract. 17 minus 8 is 9, and I have more positives, so positive 9y. These are both constants, so I can add them together. Negative 28 plus negative 8. They're both negative, so I add. That'd be 36, and it stays negative, so plus negative 36. Okay, another way we could have written that is 9y minus 36. Okay, when it's adding a negative, we can always just write that as minus. Okay, so the distributive property allows us to remove parentheses. Whoops, I cannot spell parentheses today. That involve multiplying or I don't know, was supposed to say there? That involve multiplying on the sum or difference of two or no. I don't know what that was supposed to say. This helps us to make multiplying bigger numbers an easier task. This also helps when we need to simplify an algebraic expression. So when there's variables involved. Okay, and that's it.